Hi everyone! In today's video, we're going to be going over what a vector is and how we can add it in two different ways. So first, a vector is a quantity that represents both direction and magnitude. For example, a vector can be velocity. Velocity shows the magnitude, which is the speed, and the direction, which can be represented with negative, which positive, or north, east, south, west. And there's also other ways that your teacher might represent the direction of velocity. So first, I'm going to be going over the parts of a vector. So right here we can see that this is the tail of the vector, and the part that has the arrow is the head of the vector. If we drew a vector on a graph, like so, we would be able to break up this vector into components, which are x and y components. So if I wanted to break up this vector into its x component, I would draw the horizontal part of the vector. In this case, the horizontal is 1, 2, 3, 4 units to the right. That's the x component. And the y component is 1, 2, 3, 4 units up. The first way that we can add vectors is something called the end-to-end method, or sometimes called the tip-to-tail method. So first I'm going to show you an example using vectors that don't have components, which means that they are either horizontal or vertical. So on the graph, I'm going to draw our first vector, 1, 2, 3 units to the right, and then I'm going to draw our second vector, 2 units up. Okay, so we are going to have to add this. We can start off with either the blue or the red vector. I'm going to start off with the blue vector. So the blue vector, its head is the area that has the arrow. So starting from the head, I'm going to redraw the red vector's tail at the top of the head and go 2 units up. Okay, so now we have to draw our resultant vector. Our resultant vector, the tail of it is going to be attached to the tail of our first vector that we started with. And then, sorry, wrong pen. So right here, the tail of our resultant is going to be starting where the tail of our first vector is, and its head is going to end at the head of our second vector, like so. And this yellow is going to be our resultant vector. Now, what if we started with the red first, so the y or the vertical vector first? So we remember that our vertical vector was 2 units up. Okay, so now we want to draw the blue vector. We're going to draw the blue tail attached to the head of our red vector, so right here. And remember that that was 3 units to the right, so 1, 2, 3. Now our resultant vector's tail is going to be attached to the tail of our first vector, so right here, and its head is going to be attached to the head of our second vector, so right here, and we're going to draw the resultant vector. So those are the first way that we can add vectors using end-to-end method. So let's go over a more complicated example where both of our vectors have components. So our first vector, we can say, is 3 diagonal to the right. And our second vector, starting from the origin, is diagonal to the left. So now we have to figure out a way to add these. We're going to go about the same method, which is end to end. So it's not very different from our first example. In this case, I'm going to start off with the red vector, but because it's addition, you can also start with the blue vector. So starting with the red vector, I'm going to redraw our blue vector, and it's going to be starting at the head of our first vector. So diagonal to the left. And now we're going to draw our resultant vector. The tail is going to be attached to the tail of our first vector, and the head is going to be attached to the head of our second vector. And this would be our resultant vector. So now what if we wanted to subtract vectors using end-to-end? So let's say I have two vectors again. This one is 4 units to the right, and this one is 2 units up. Let's say I wanted to do red vector minus blue vector. Before we do that, let's look at how we add and subtract normal numbers. So we know that a minus b is equal to negative b plus a. In this case, our a is going to be the red, and our b is going to be the blue. So if we wanted to do a minus b, we would have to negate our blue vector. And negating our blue vector would mean having it in the opposite direction. So if that was 2 units up, our new vector is going to be 2 units down. So this is going to be negative b. So now using our end-to-end method, we're going to have to do negative b plus a. So I'm going to start off with red again, and I'm going to redraw negative b. From the head, I'm going to draw it down 2 units. Using this, I'm going to draw a resultant vector, like so. And that yellow is going to be represented negative b plus a, or that's what a minus b is going to look like. And our last example of using end-to-end method, we're going to practice adding more than 2 vectors. So again, I'm going to use our a plus b plus c. We know that a plus b plus c is also equal to c plus a plus b, which is equal to b plus c plus a, and so on. Because it's addition, we can change around the orders of our a, c, and b. So let's say I have 3 vectors. In this case, I have 2 units to the right. That's 1 vector. I have 4 units up. That's 1 vector. And I have another vector that is diagonal up and to the right. Okay, so we can choose any of these 3 to be A, B, and C. We can do red and blue, red and yellow, or blue and yellow as our first addition. So the easiest way to go about this is to choose our A and B and add those 2 together first. So you can choose any of these 3 to be your A and B. In this case, I'm just going to choose the red to be A and our blue to be B. So now I'm going to do end-to-end method on A plus B and redraw that new resultant vector. So starting with blue, I'm going to redraw blue onto the red, like so, and then add the resultant vector with green so we can tell the difference. Sorry if it's a bit messy, but that green is going to be what a plus b is. So now that we have a plus b as a new vector, we just need to add c to get our final result. And now that we have a plus b, we can remove our components of the red and blue. And now we have to add the a plus b vector, I'll label it here, plus our c vector to get the final result. So again, using end-to-end method, I'm going to start off with green, and I'm going to redraw the yellow onto the green. So 4 units up, and I'm going to draw resultant with red. Tail here, head here. And that is going to be our resultant vector of 3 different vectors. Using end-to-end method can help us figure out the direction of our vector really easily, but sometimes it can be hard to figure out the magnitude. So again, I'm going to reintroduce the components of a vector. If we had a vector like so, we would break it up into 2 components, the x component again and the y component. Our x component would be 1, 2, 3, 4, 5, 6, 7 units to the right, and our y component will be 1, 2, 3, 4, 5, 6 units up. So this image should remind you of a right triangle. And with right triangles, we can do trigonometry. If we know that our x component of our red vector is 1, 2, 3, 4, 5, 6, 7 units to the right, and our y component is 6 units up, we can figure out the magnitude of our resultant vector, or of our original vector. And because this is the right triangle, we can use Pythagorean theorem. If our red vector magnitude is going to be the hypotenuse, we can say that magnitude of the red vector is equal to square root of 7 squared plus 6 squared. Using a calculator, I'm going to do 49 plus 36, and that's going to be square root of 85. So now, another helpful thing that is important in vectors is knowing the angle against the horizontal. And this angle I'm going to call theta. So in most cases, the components we have are the x and y. And we know that tangent of this theta is equal to opposite, which is y, over adjacent, which in this case is our x component. And we want to isolate theta. So theta will be tan inverse of our y divided by x component. So in this example, theta against the horizontal is going to be tan inverse of 6 divided by 7. And using a calculator, 6 divided by 7, it is about 40.6 degrees. And make sure your calculator is in degrees when adding and subtracting vectors in physics. For our last example, we're going to be looking at adding 2 vectors that both have components. So, we're going to break up our red vector into 2 components. First, we're going to have our x component, 1, 2, 3, 4, 5 units to the right. And our y component is 1, 2, 3, 4, 5 units up. So looking at our red components, our x is 5 and our y is 5. Now, we're going to break up our blue. Our blue is 2 units to the left. And when we're looking at the left, we're going to say it's negative because it's opposite to the right, which we're going to consider positive. So our blue is -2 to the left and +2 up because up is positive and down is negative. So our blue components, our x is -2 and our y is 2. So now that we've broken these up into components, we can just simply add the x's together and the y's together. So we're going to look at our net. Our x would be 5 minus 2, which is 3, and our y's would be 5 plus 2, which is 7. We have our x and y components, and now we want to have the magnitude. And remember, magnitude is calculated using Pythagorean theorem, which is going to be 3 squared plus 7 squared, which is equal to square root of, let's check with the calculator, 9 plus 49, square root of 58. And our angle against the horizontal is going to be tangent inverse of, remember, y over x. So 7 divided by 3, which is about 66.8 degrees above the horizontal. So now that we have this, we can draw out our resultant vector in green, starting with our components. So we know we have 3 to the right and 7 up. And kind of like end to end, we can add up these x and y components for our final resultant vector, which is going to look like this. And I will highlight it. And this is going to be our final resultant vector. Thank you so much for listening. I hope this video was helpful. And if you need more practice, I have linked down below a worksheet with more vector practice for you to do. Thank you.